Hi everyone, and welcome to the third of 4 videos going through some past exam questions on ligand substitution and precipitation reactions of transition metals. The first question we've got here, let's have a look. What does it say? So we've got Fe2 plus ions can be used to test for nitrate ions. This is all going to be waffling. 2 reactions are taking place. Right, fine. Construct equations for these 2 reactions. Okay. Right, so reaction 1, what's happening here? In acid conditions, Fe2 plus ions reduce nitrate ions to NO. Fe2 plus ions are oxidized. Water also forms. We want to write an equation. Now this, we've got to be a little bit careful here because obviously this is a redox reaction, right? Something's being reduced, something's being oxidized. So this is going back a bit to prior knowledge here of how do we construct redox equations. And what we're going to have to do here is do 2 half equations and then combine them together. So I'm definitely going to do some rough working here before I go and write my equation. So we want to write 2 half equations, right? So it's saying in acid conditions, Fe2 plus ions, they reduce NO3 minus ions to NO. Okay, so that's going to be one of our half equations, is NO3 minus ions going to NO. And the Fe2 plus ions are oxidized to Fe3 plus. Okay, so that's going to be the other one. So that half equation is nice and easy, isn't it? All that's happening there is that's being oxidized, it's losing 1 electron. So that's super easy. Here, let's work this out. We're going to have to do oxidation numbers, aren't we? So here, the oxygen is going to be -2. There's 3 of them, so that makes it -6. It needs to add up to -1. So the nitrogen here is going to have to be +5. And here, oxygen's -2, so the nitrogen must be +2. So therefore we're going from +5 to +2, so it's been reduced. That means it's gaining electrons, and if it's going from 5 to 2, it must be gaining 3 electrons, so we must have 3 electrons here. Okay. Then if you remember, the process for sorting these half equations out is we need to balance the oxygens by adding water molecules. Okay, and we can definitely do that because it does say up here, look, water also forms. Okay, so we're definitely happy to do that. So we need to add water here. And we've got 3 oxygens, and I've got 1 there, so I need to add 2 H2O there. And then I can add my 4 H plus ions onto this side of the equation. Okay. And then we can check the charges balance. I've got 4 plus, and I've now got 4 minuses as well, 1 from there and 3 from there. So no charge overall on that side, and no charge here, so that's good. Okay. And again, there was a clue to this, that we could add the H plus ions here, because it does say up here, look, in acid conditions. So these are my 2 half equations. If I'm going to combine these 2 together, I need the electrons to cancel out. So therefore, I'm going to have to multiply this equation by 3, aren't I? So let's do that. And now I can add these 2 together to make my reaction. So I'm going to end up with 4H plus NO3 minus plus 3 Fe2 plus goes to 3 Fe3 plus NO plus 2H2O. Okay. So that's my reaction for that one. Right, and then reaction 2 says a ligand substitution reaction of this iron hexaaqua takes place in which 1 NO ligand exchanges with 1 water ligand. Okay, so that's quite straightforward. So we've got FeH2O6, and we've got 1 NO going on, so that's going to make FeH2O 5 NO, and an H2O is going to come off, right? And the NO ligand has no charge, does it? It's not an ion. Okay, so that shouldn't change the charge on this complex, right? So it's still going to be a 2+ charge here. So hopefully that's not too bad. Okay. Okay, let's have a look at what else we've got here. Right, here we have, this question is about the chemistry of copper compounds and complex ions. Flowchart shows 2 reactions of aqueous copper 2 sulfate. Write the formulas and the colours of the complex ions formed. Okay, and if you've watched previous videos on this topic, you should know what these answers are already, right? One of the good things about this topic is it's very repetitive, right? There's only certain things they can ask you about. There's only certain things on the specification that says you must know what this is. And for copper, this is it. These are the 2 reactions that you need to know. Okay. When you do a ligand substitution with ammonia, it only substitutes 4 ammonia ligands on. So we end up with this complex ion with copper, NH3, 4, H2O, 2. And if you've practiced this a bit, hopefully you're starting to get comfortable with this. And it's copper 2 here, isn't it? So this is going to have a 2+ charge because none of these ligands have any colour. Sorry, none of these ligands have any charge. These are neutral, these are neutral. What colour is it going to be? This is a deep blue colour. Remember the copper sulfate, copper 2+ ions are a pale blue colour. And then you get this deep blue colour with the ammonia complex. With HCl, it's chloride ions that act as the ligand. And again, you only get 4 ligands for chlorine. But those 4 chloride ligands swap for the full 6 water ligands from the hexa-aqua complex. Because this copper sulfate aqueous is actually this complex, isn't it? It's actually that and a sulfate ion. Okay. And so we're going to substitute these 4 chlorides for those 6 waters. So that's going to make this complex. If it had a 2+ charge to start with, it's got 4 negative chloride ions. So it's going to have a 2- charge now. The 6 waters have all come off. And the colour of this complex is yellow. Again, these are just things that you need to remember. Okay. So that should be a question that you're looking forward to, right? Don't go into your exam not knowing this. Okay? You should be absolutely prepared for that. This is going to come up and it's this and it's blue. This is going to come up and it's yellow. Make sure you know those. Okay, this question then says we've got hydroxide ions and cyanide ions. They can react with some aqueous solutions of transition metal compounds. Okay, nickel 2 sulfate is dissolved in water. Pale green solution forms containing a 6-coordinate complex ion. Aqueous potassium hydroxide is added. We get a green solid. Right, I want to make a point here. Again, if you've watched previous videos in this topic, I'm just finding there was a very, very similar question. Here we go. This was from a previous video. Nickel 2 sulfate. What have we added? Oh, we added hydrochloric acid, which we haven't got in this question, but sodium hydroxide is added and you get this precipitate. Oh, we've got nickel sulfate again. Potassium hydroxide is added and we get a green solid. So they're very... they're not very imaginative with questions. The same kind of things keep coming up here. So let's have a look. What are we doing? Nickel is dissolved in water. A pale green solution forms containing a 6-coordinate complex ion. Oh, so if this has just been dissolved in water, this is just going to be, if it's 6-coordinate, this is just going to be the hexa-aqua complex. Okay. And it was nickel 2 sulfate, so it's 2+. Solid D, if we're adding hydroxide ions, it's going to make a solid. That's going to make nickel hydroxide. It's nickel 2 hydroxide, 2+ charge. Complex ion E, excess of potassium cyanide. Okay, this is a bit different. Potassium cyanide is added. Yellow solution forms containing a 4-coordinate complex ion that contains only nickel, carbon and nitrogen. Okay, well I'm assuming that's just going to be then nickel with 4 cyanide ions as ligands. Okay, but then when you think about what the charge is going to be, cyanide ion would have a negative charge, it's Cn-, so 4 of those have gone on, and it was 2+ originally. It's now going to be a 2- charge. Okay, the fact that it says it only contains nickel, carbon and nitrogen is important, because that's telling us that there aren't any water ligands still left, right? It must have substituted 4 cyanide ions for all 6 of the water ligands. Okay, and then it says write equations and name the types of reactions. Okay, so forming the solid D, so forming this, write the equation for that. Okay, so this is our nickel H2O 6. As a sort of an aside here, there's various ways you can write this. So you could just write this as nickel 2+ ions, like as an ionic equation. You don't actually have to write the full complex ion here. It doesn't really matter, but since we've started with that. And then what we're adding here, again, you can do this two ways. You can either write potassium hydroxide, or you can just write hydroxide ions. So let's say I'll go with 2 OH minus ions. We end up with this as our product, and the 6 waters come off. Okay. But you could use potassium hydroxide here and then have K plus ions at the end. You could write this as a complex ion with OH and still have some water molecules there, but I think that makes it more complicated than it needs to be. So there are lots of different ways you can write that equation, but that's the way I would write it personally. And this is a precipitation reaction, isn't it? Because this is a solid. And formation of complex ion E from C. So again, we're starting with our hexa aqua. And we must be adding the 4 cyanide ions. Again, I could have potassium cyanide here. It doesn't matter. And then I'm going to end up with my complex over in here. And the 6 waters coming off. Okay. And that is a ligand substitution reaction. Okay.